Raju Vatsavai. I'm Professor of Computer Science at the North Carolina State University, and I'm part of AI Climate, investigating on bringing AI to forestry sector. I'm also a graduate of University of Minnesota some 25 years back. So there is strong connection in that sense. So the research that we are doing at North Carolina State University is focusing on advancing AI to accurately map forest losses. Losses can occur from wildfires to disease or impact of environmental changes like land degradation. And we are tackling core challenge in forestry using remote sensing, such as limited ground truth data, spectral ambiguities. Sometimes same species can have different spectral properties. Conversely, different species or same species can have different spectral, as well as different species can have same spectral, depending on like spatial location and land structure at a given location, and also the plant growth stage at that given time. So all these will reduce effectiveness of machine learning models, and we are addressing these challenges by integrating diverse knowledge sources and data sets. Our work directly connects and enhances AI leaf machine in two primary roles. One, first as a consumer of AI leaf resources, and second as a producer for AI leaf ecosystem. So first, as a consumer, we are actively investigating and benchmarking foundation models for downstream machine learning tasks, especially in deforestation, understanding deforestation. So by collaborating with the Professor Kumar's group at Minnesota and Bharat Hariharan's group at Cornell, who are developing these very specialized foundation models that are pre-trained on large data sets. We are hoping to further improve our model accuracy and its generalizability for global scale. Secondly, as a producer for AI ecosystem, the high resolution cause specific deforestation maps that we are generating using AI, we are hoping it will become a key data product to the AI leaf ecosystem, as it provides essential ground level intelligence for conducting downstream work such as greenhouse gas emissions or assessing environmental impact. So these are the two primary roles within AI leaf ecosystem that we are performing. On the advancing AI side, to solve these tasks, we are developing semi-supervised deep learning framework in collaboration with Professor Shekhar. This addresses specific problem of limited ground truth data. And of course, there are several solutions to do this. So what uniqueness of this solution that we developed is it works not only with extremely limited ground truth data, but also when those labels are limited to only one class. Like deforestation, we have few samples, but for all other classes around the deforestation, we don't have any ground truth, right? So this solution particularly addresses that limitation. In addition to AI Leaf Institute, we are also developing external collaboration. Example is CAMCOR, which is an international tree breeding organization. And we are applying the techniques that we are developing in AI Leaf, bring that to solve practical challenges faced by CAMCOR, which is optimizing the selection of resilient forest genetic material for changing environments. So typically in machine learning, we look at the past history to make the prediction, but CAMCOR problem is when you are predicting a species, not it should survive not just in the current conditions, but also like changing temperatures or changing precipitation uh, during the lifetime of that tree. That means we have to look at climate projection data as well. So by integrating all these diverse data sets, we are trying to improve the forest breeding programs headed by CAMCOR. Those are some of the current research, and I just told you how it connects to AI Leaf. What inspired my research at the intersection of AI and environmental sciences? I would say it is somewhat happened accidentally because my first journey into the field somewhat began in Government of India's National Forest Data Management Center, which was tasked with digitally mapping the state of India's forests. Uh, like they are like vast area covering almost a quarter of the country's land mass. And that experience was my inspiration. That is the first time out of undergrad studying mathematics and computer science, suddenly I was exposed to these environmental problems. What is the cause of that influence is first the technological challenge. In 1990s, when I started this, it is very I would say, first movement of moving from manual techniques into digital world by applying digital processing and pattern recognition techniques, which are precursor to the current modern AI. Those techniques were emerging in 1990s. I'm one of the first guys, at least from India perspective, we were recruited to do that work very first time. And also during that process, I gained deep appreciation for the complex and competing pressures of forest resources from both social, economic needs of the population that depends on forests, and as well as the need to protect the forests, because officially there are like almost like a quarter, I said 24-25% of India's land as designated as forest. But unfortunately, when we started using these digital technology to map, only 19% of the land turned out to be forest, right? That is a big gap then between the perceived forest area versus actual ground, how much forest was there. And like I said, there is a lot of pressure from people around forest areas, and people depend on forest products. That competing goals help me to better appreciate why we need to do this. And that foundation guided my path for almost like last 30 years. So even during my graduate studies at University of Minnesota, my work is sort of a bridge between computer science and forestry departments, which is focused on using machine learning techniques and remote sensing data to improve accuracy of forest inventory estimates. And that foundation helped me my later collaborations while I was working at Oak Ridge National Lab. It helped me to develop several collaboration with federal agencies where I studied real world impact of government policies, for example, like biofuels program and its impact on land use changes. For example, if you considered Midwest, continue the corn rotations between wheat and soybean are becoming continuous corn production because the desire for more biofuels and those kind of changes. For example, if happen in countries that depends on population depends on more food crops, like for example, India, even small percentage of the changes in crops converting food crops into energy crops, that has a big impact. And I studied those kind of impacts of government policies on land use, land cover changes. AI provides scalable, very precise tools that we need to map, monitor, and protect our natural resources at a global scale. It is the key to quantify these complex environmental and societal trade-offs and building more sustainable future. So that's my motivation and inspiration of working at the intersection of AI and environmental sciences. So, like I mentioned earlier, our project addresses core challenges in land management practices. Uh, the historical practices are becoming sort of obsolete due to environmental changes. We are developing AI-driven decision tools that are predictive rather than reactive to help forestry and as well as agriculture to adapt to these changes. In the case of forest sustainability, the current practices of selecting tree species based on past and present conditions. However, if you considered planting tree today, they will face very different environment over its long lifespan. So in collaboration with Camcor, we are building models that integrate diverse data from field genetics to scale using satellite imagery and climate projections to recommend forest genetic material optimized for future climate scenarios. This kind of approach ensures high survival rates, better productivity in the long run, and more resilient forests for the forestry companies that depend on health of these forests. For improving crop productivity, we are developing knowledge-guided machine learning approaches to optimize fertilizer application. First, it saves farmers money on the cost of inputs and it boosts productivity. So increasing crop yields by precise management of nutrition is the key to improve productivity. And also this practice, adaptive fertilization, improves or protects our environment because it significantly reduces fertilizer runoff, which is a major source of water pollution. And finally, I would like to mention what kind of collaborations that we would like to happen between NC State and AI Leaf projects. First, our work, which recently accepted at a ACM SIG Spatial GIS, is looked at how we can leverage the foundation models to improve downstream machine learning tasks because building foundation models require um, uh, humongous amounts of computational resources and very big data sources. So everyone cannot do that, but everyone can benefit from these foundation models. So coming to AI Leaf, the groups headed by Vipin Kumar at Minnesota and Bharat Hariharan at Cornell, they are building very specialized foundation models. And my collaboration with our collaboration with these folks at Minnesota and Cornell could help us improve downstream machine learning tasks like identifying um, identifying deforestation. I'm already collaborating with Professor Shekhar at Minnesota to improve machine learning models under the scenarios where you have very limited ground truth data and also you have ground truth, very small ground truth for only one class, such as deforestation. By looking at both, by bringing constraints like spatial homogeneity, heterogeneity under changing scenarios across the globe. Finally, we would strongly benefit by expertise of Professor David Muller in improving fertilizer application that we are developing. And with his help, we want to bring this to the farm scale by integrating the solution on edge devices to predict adaptively based on the current conditions at a location to decide whether to apply fertilizer or herbicide and by how much quantity. So these are some of the collaborations that I have in mind going into the future.